D.2, string matching. For this part D, because D.1, I used 36 minutes. It is very long. So for this part, we can only have 2 videos, D.1, D.2. Yeah. All right, so D.2, we will solve a new problem, string matching problem. Yeah. When we work on this problem, there are several things we want to learn. The first thing is mathematical representation. Okay. All right, so look at our problem. Problem number 6, string matching. Yeah. Given a string of n characters, we call it text, a block of text, n characters containing space. Okay, all the characters in a sequence. So we consider array of characters. Yeah. And a string of n characters to compare, so we call it pattern. So we want to match a substring in the text to this pattern string, another, shorter string. So pattern with m less than or equal to n. Yeah. Requirement: find a substring of the text that matches this pattern. So what do you mean find? What is the output? Right? We want to know what is the output. Suppose we get a match. Yeah. One substring matches this pattern. What do we return? Right? Yeah. Location. Find its location. Location of the substring. But how do you describe the location? Right? You have many characters in this substring. How do you describe this substring? Yeah. The index I of the leftmost character. We use the leftmost character, not rightmost, leftmost character, index of it. Yeah. All right. Now let's solve it. The first solution, straightforward solution, the brute force method. Yeah. All right. So here, after we have the first solution, usually we should look at second solution, right? Yeah. But for this class, we will not do that second solution. The second solution is given in the textbook. It is very complicated. Very, very complicated. Yeah. So we may not have a chance to study that second one. If it's possible, I will try, but based on my experience, we may not, because this semester is very short. Yeah. All right, but the first solution, it is a simple solution. We have a lot of useful things we can learn. Yeah. First, mathematical representation. First, we need to represent the problem using some formal, nice way. Here, we use symbols to represent this problem. Yeah. All right. Importance of mathematical representation, because we can apply mathematical tools. Yeah. If we do not have a good mathematical representation, then a lot of advanced math tools cannot be applied. Yeah. So that's why this representation is very important. Yeah. All right, so next, the formal representation. Text. How do we represent given text? A sequence of characters. We use little t, subscripts, t0, t1, the last one, t sub n minus 1. Then the pattern, we use p sequence, character sequence P0, P1 through P sub n minus 1. Okay? All right, so then the requirement. For the requirement, find the location I. So this I location, suppose we find a match. How do we describe the match condition here? All right, very simple. T sub I equals P0. Then T sub I plus 1 equals P1, and so on. Okay? The general case, P sub I plus J equals Pj. The last one, P sub I plus n minus 1 equals Pn minus 1. That simple. Okay, one by one, the corresponding positions all matched in a perfect way, then we get a solution. Okay. All right, so next. First, we want to figure out property. So for this problem, we try to get some useful information, the properties. Here, I like to introduce a commonly used strategy in problem solving, guess and verify. You make a guess. Okay? When you try to find some useful information, at the beginning, you can make a guess. But when you make a guess, it could be wrong, correct or wrong, all possible. Yeah, it could be wrong. Then you need to verify. You need to do some verification. Otherwise, you don't know if your guess is correct or not. So guess and verify. This kind of simple, basic approach. Yeah. Here, use this example. I will show you how to use it. Later, we will use this strategy many, many times. Yeah. All right. Thinking. Yeah. Question. Can we exhaust all such M substrings? For a match, we need to, the first natural thinking, we want to exhaust all M substrings in the given text. For each one, we try to match against the pattern. Yeah. All right. So based on our intuition, the answer should be yes, right? Yeah. Yeah. Very obvious. Yeah. All right. So if we can exhaust, so every time, let's just take one of the M substring. Yeah. Just take one. Okay. Yeah. Then we can do comparisons. Yeah. Character by character. Okay. Yeah. After we compare all M pairs of characters, yeah, then we know if it is a match or not. Yeah. All right. So compare it with the pattern for a possible match. Yeah. All right. But now, to move one step forward, we need to ask another question. How many such M substrings? We want to count the number of such M substring. M substring, we mean this substring has length M characters, consecutive characters in the given text, yeah, M substring. Yeah. How many such M substring? Simple counting problem. Yeah. But if we are not very careful, you may get a wrong answer. Yeah. So here, let me show you how to use that guess and verify strategy. So let's make a guess. So what's the answer to this question? Okay, yeah. All right, because the total length m characters, one substring occupies m characters, right? Yeah, so, large part, starting from there, so then count until you reach the right end of the text string, right? Yeah. So it looks like, based on your intuition, it looks like your guess likely to be this n minus m, right? N, total number of characters, that m string number should be smaller than n, right? Yeah. So n minus the leading part, the m, right? Yeah, but that's the guess. It may not be correct. May not be very, very precise. So you need to verify it. You need to verify if this answer is correct or not. How do we verify? We want to use a simple example to check it. So what kind of simple example? When m equals n, the pattern and the text, they have the same number of characters. It is a special case, right? Special case. But if you apply your guess formula, m minus n, you will get zero number, no, but you can get an answer. There is one m substring in the given text, right? The same length, so you should have one. That whole text string, that's the one m substring, right? So your answer should be 1, but here it is 0. That means this guess is just a 1 short of the real answer. Just a 1 number short of the real answer. So you fix it by adding 1 to your guess. So your real final answer, n minus m plus 1. Yeah. So that's the guess and verify strategy. Very simple and very effective. Yeah. All right, so let's go to the next part. Yeah. Implementation details. This time we want to solve it. Yeah. Solving the problem, pretty easy. Yeah. We know the total number of m substrings. We just go one by one. Every time we get a 1m substring, compare, match or not. If it's a match, we return the location. The function terminates. If not, so we keep doing comparisons like that until we reach the last m substring. All right. Here, let me use this diagram representing the whole text. We try to get some m substring information. All right. First, let's look at our first m substring. So for the first m substring, here you can see its location is I equals 0. I equals 0. Okay, all right. Then, what is the location of the last m substring, right? Yeah, because when we write a program, we want to from the location I from 0 to the location of the last m substring. But we need to find it. Otherwise, how can we write our program, right? So this is a critical number we need to figure out. Yeah. How to figure out, guess and verify. Although you can try, but here I like to introduce another very useful method in problem solving. Later, many places we need to use this method. Yeah. So what's that? Yeah. All right. Here we want to figure out the subscript of this question mark. that location. Okay, yeah. But the method we want to use, we call it invariant. So here I call it invariant idea. Invariant. No change. Invariant. So what's that invariant idea? Yeah, let me describe it. Yeah. All right. Here, let's look at the difference of two n subscript of each m substring. Okay, each m substring. The first m substring, 2n subscript, n minus 1 minus 0. So that's n minus 0, n minus 1, right? Yeah. So the first one, n minus 1 minus 0, n minus 1. That's the difference. All right. Now, think about when you move your m substring one location to the right, every time one location to the right. The rightmost subscript increased by 1, leftmost subscript also increased by 1. Same number, right? Rightmost increased by 2, leftmost also increased by 2, right? The number increased for both subscripts the same. If that's the same, their difference also keeps the same. Okay? So that same number difference, we call it invariant. That's the invariant. It never changes. When you move the location of the substring, m substring, that difference never changes. That's the invariant. In the moving m substring, your substring moving, changing, but one quantity never changes. That quantity is important. Yeah. So we use that invariant, we can figure out this location, question mark location. Yeah. All right, so let me show you. Yeah. Here, the difference of those two numbers. Here I use question mark, I use x to represent. Yeah. Unknown, so we need to solve for this value, x. Yeah. Unknown. Yeah. So n minus 1 minus x, the difference of two n subscripts must be the same as n minus 1, or the first one. Yeah. So we set up this equation. Can you solve it for x? Very easy. We can find a solution. X equals n minus m. Solution. Yeah. That tells us the location I of n minus m. That's the location of the rightmost m substring, the last substring. That's the solution. Okay? Yeah. All right. So you can see this method is very useful. Very useful. Okay? Yeah. Usually it's not very easy to find that invariant. But if you have a lot of training like this, so you may get used to it. So you will get used to it and you can apply this method to solve real world problems. All right, so next, do simple analysis. Yeah. So that's pretty easy, pretty straightforward. Yeah. Best case efficiency. When you compare the first m substring, you get the solution. Okay. So, but you need to do m comparisons, right? You need to check all m characters to get that conclusion. Yeah. All right, the worst case efficiency, you need to compare all the m substrings. Yeah. So that's each m substring, you do m character comparisons, but you have this many m substrings. Multiplication. Yeah. Average case, that's simple, adding two numbers divided by 2, because this one, you can see every time each case, the parenthesis number increased by 1, right? Yeah. In that pattern, So you can see, it's easy to see this is the average case number, comparison number. Yeah, here, for one comment. So when I ask you average case efficiency, here I'm talking about the average case efficiency. When I ask you that, it is allowed to use non-integer number. Fraction numbers. Yeah. Because I notice many students, when I ask them average case efficiency, when they get a, some fractional number, they drop the fractional part. They just give me the integer answer. Not necessary, because when you do average, we expect to get non-integer number. Okay? It's very common, very normal, so do not drop the fractional part. Keep it. Yeah. All right. So that's the video D.2, and we used up our required time for this part. So I have to stop here.